Raise your hand if you think generative AI is a transformational technology for both governments and enterprises. Can we have a show of hands, please? All right, perfect. Now raise your hand if you have adopted or implemented generative AI in your enterprise. I'm not talking about ChatGPT, but on a more sense. Interesting. What's even more interesting is that it's a global pattern. According to a Gartner survey, more than 70% of global technology leaders and CIOs agree that this is a game-changing technology. But only 9% has ever implemented or adapted AI, this technology, to empower their businesses. And this is very fascinating because for a technology that is so innovative and that is so obvious of its potential, why are the adoption rates low? And that's exactly what we'll be looking at today. Why is this the case? Why haven't we fully realized the full potential of generative AI in the enterprise? So at Rootcode, we work across a range of industries, ranging from manufacturing to optimizing power grids to working with some of the world's largest food and beverage manufacturers to optimize their supply chain systems. And throughout this experience, I've been fortunate enough to work with some of these enterprises and the technology leaders on top to witness how they adopt their enterprise AI strategy and even guide them through it. And through that process, I have also come to learn some lessons that these enterprises, that we learned when working with these enterprises. Some we learned the hard way, and that's what I want to share today with you, so that when you go back and when you start your enterprise AI strategy, you can use these out of the box. All right. So let's start with data. As with anything in AI, we cannot talk about AI without talking about data, right? And I think most enterprise strategy leaders in this room would agree with me that one of the major blockers for adopting AI in general itself is data, right? So, and data is one of the most common bottlenecks, like we spoke about too. So, the context here is, we were working with one of the world's largest food and beverage manufacturing firms. And this firm has more than 1,000 plus products in their supply chain. And so that quickly meant that they had this complex web of thousands of distributors and transportation systems and routes, building up to a complex graph of a supply chain that is so interconnected. The problem was when they wanted to make major strategic changes, it was nearly impossible to predict the ripple effects on this particular supply chain system. So when we work with them, what we decided to do was we wanted to apply generative AI models to simulate and forecast these supply chain disruptions before they become obviously clear. So this was a pretty straightforward problem when we started out. Was the data available? Yes, we had it. Was the compute available, which is another major thing needed to implement AI successfully? Yes, we had it too. So it was pretty straightforward. So I flew over to their office, to their HQ to meet with some of the supply chain directors. And it was a room full of 10 to 13 directors and from different business units. And they were coming and presenting on how they were optimizing their supply chains. And as they started presenting, it came clear to me that each of them were islands of their own when it comes to data. It was as if they were solving this major puzzle, group stops them, focusing only on their area where nobody had the whole picture as a whole because the data was so siloed. So we finished the meeting and I went to the CEO and told him, we first need to fix this data issue. And this is not a special case. This is common for many enterprises where it's inevitable that their data becomes siloed. Different division, in this case it was different business units, but sometimes it's different divisions of operations and HR and finance. And this segregation of data becomes a major bottleneck. And if we went ahead and deployed our generative AI simulation models on this particular supply chain, we would just simply be adding to this chaos, causing even more segregation between the data. So, to start out, we wanted to create a data fabric. And this is one of the most popular strategies currently, a model strategy to enable AI in the enterprises. So how did we do it? So the first stage in creating a data fabric is the collection layer. Now in this case of this particular manufacturing firm, we had enough data coming from different sectors. We had data coming from the production lines, we have data coming in from the suppliers, but they were all collected and stored in different units. And the first layer was to aggregate and create data pipelines that combine all these. And then we had the organizing layer where we added metadata, cleaned and treated the data as a product instead of a byproduct of business operations. And then we will have the analysis layer where we'll analyze the data and we'll have the BI analysts who would produce intelligence on top of the data. And then we have the infusion layer where we build our AI apps on top of. Now the trade-off here was, obviously it costed us a little bit more time, but it enabled us to develop this totally vertical integrated stack where they had their compute layer at the bottom. And then we built these connector architectures, which again created the data as a product so that it's treated as it should be and it's maintained and governed consistently. And then we built our AI application on top of it. And what this enabled us to do was to finally provide the big picture to the AI model. And this the AI model was finally able to do global optimizations to the entire supply chain instead of only focusing on local business units. And now thinking in retrospect, it's nearly impossible for groups of humans to even imagine and optimize such a huge and complicated supply chain just by using the data they had at hand. And the results were pretty amazing. The simulation model, the generative AI-based simulation model, cut down the supply and transportation cost by nearly 32% just within the first few months of deployment. And what's even more interesting was that it forecasted the ripple effect of a major policy decision taken for that particular industry that passed around the EU and provided recommendations to make the supply chain more resilient instantaneously. And this is something that would have generally taken a week or two for human supply chain experts to come out. But immediately as the policy decision was taken, our model was able to simulate the ripple effects of it and provide recommendations. And this was because modern generative AI models, we were able to connect it to the internet to constantly monitor for major decisions being taken around that industry. And it also, we actually made it one of our training goals to cut down their carbon emissions of the entire global supply chain, and it cut it down by nearly 15% in just the first few months of deployment, which had a major impact. And the best part here is not just the results. Now, since we have a totally vertically integrated data stack, the model gets better consistently over time. Of course, we'll have to maintain it, but it wouldn't go easily outdated because there's a constant inflow of data coming into it all the time, and it's in real time. All right, so Now we were talking about the strategic layer, the technical implementation. Let's move a bit on to the human capability here. Because, end of the day, that's whom we are building for, right? So this is a story of how we use generative AI to augment human capability. So we were working with Kendrion, one of the world's largest electromagnetic and sensor manufacturer. Their equipments and their sensors and actuators run in every part of modern infrastructure, so to say, from automobiles to escalators to lifts, everywhere. But this also meant that they had a very complex production line. This production line was producing data at every single point, and there were hundreds of different equipments they were manufacturing. And the problem is, Kendrion is a 100-year-old company. And this is a classic example of a very traditional enterprise which had rigid policies. So this also meant that they had more than 1 million documents internally containing a massive volume of knowledge, because at each step in this production line, there was so much of information being generated. But even though so much of data was being captured, when the strategic leaders asked the big questions like, how can we optimize our production lines to reduce carbon emissions, or what were the supply chain issues we had, it was a week-long process to get the data, to get it through the analysts, to extract the data, and then get the answers out of it. And by the way, this wasn't a new problem in Kendrion. This was more than 100-year-old problem since the time they started their first production lines. This problem has existed. But we also realized that solving this problem would mean that the senior leaders in the organization would get so much of value and so much of accelerated pace in their decision making. And that's what we wanted to target as the first part of their AI strategy. So before we directly go into the solution of how we did it, we'll have to take a step back and see how the concept of large language models can be applied here. So every LLM, all of us have used GPT-4 or GPT 3.5 to some extent. GPT 3 and 4 to some extent, and we start with the pre-training stage. This is the fundamentals of how many LLMs are trained, where we have an initial training set, and we ask the model to extend it so that we give an initial data set and ask it to predict what this sentence would look like if it was continued into the future. Initially, it generates some gibberish, but when we go forward, after enough training on massive volumes of data, in this case, we gave it a Shakespeare text, it's able to generate a similar quality output that is so similar to what Shakespeare would have written, right? But still, this model is not useful. We need to train it to generate answers and create prompt response pairs. So what we do here is we simply, since they already have a fundamental understanding of language, we create prompt response pairs, and we train the model to understand language. Now, after this massive volume of training, this is what we get. These are the most common large language models. We have GPT-4 from Google Gemini to Anthropic Claude. This is the fundamental of the entire training pipeline. And what we get after that is a model that can even explain the fundamentals of complex nuclear physics in one paragraph, or give you a desperate attempt at, give you some support at your desperate attempt to convince your boss that he should be taking you to a yacht party in Dubai. But what's more interesting here, rather than my attempt at trying to convince Alagan to take us to a party while we are here, is that I'm asking it to give me some ideas on how I can persuade Alagan, given a message he has sent me. Now, the answer it generates is totally customized to the narrative Alagan is saying. And this particular message, which Alagan has sent me, has not been in GPT's training data. But it's still able to tailor its answer to this particular question. And that is what makes these models so powerful. So now coming back to Kendrion, how can we apply this to 1 million more documents. One obvious strategy is we just, similar to GPT-4, we just directly attach all the documents, pass it to an LLM and train it, right? But the bigger question comes in, and this is a question that many enterprises would face. What do we do for new documents? Many enterprises like Kendrion are like data factories where at each point in their production line or supply chain, they're producing so much of data that simply training a static model would make the entire model and the application go outdated just within a few weeks because there's so much of new data being produced. And this is where we took up this approach of retrieval augmented generation. This is, again, a new approach that's being used with LLMs. That's an alternative to training. What we do here is that instead of simply training the entire model with all the data, we first build the data fabric at the bottom, and we then create a knowledge base and build a search engine layer. So that when a user asks a question, we extract and we figure out what are the documents that could potentially contain the answer. And then we pass just those documents to the LLM. And now since the LLM has a really high quality context of what the answers to the question should be, it can generate the answer more accurately. And one of the most important concerns when building generative AI applications, I think even globally, is avoiding hallucination, right? And in our case, since we were building a tool that is going to be used by leaders at the top of the organizations to make decisions, we had to make sure that this tool doesn't just come up with information just for the sake of answering. Now, for example, over here, I'm asking about, tell me about Nanurid, the AI startup changing the world, and it's going on and on to explain about this amazing AI startup and the work they are doing. Nanurid is just my name spelled upside down. So there is obviously no startup as such, but it's still hallucinating, right? And one of the most straightforward yet effective strategies is explaining the guardrails or explaining the boundaries of the system to the LLM very clearly. Now, for example, here we are constraining the system to just answer the questions based on the documents and not from its internal knowledge. Generally, some of the more advanced guardrail approaches require training, but this is simple yet very effective. Now, what this entire strategy helped us to do, this change in strategy from just training the LLM to using retrieval augmented generation, is that it helped us optimize the training costs a lot. And training costs are one of the most expensive steps of any generative AI pipeline. But what it also enabled us to do is it gave us unlimited scalability over the documents so that we do not have to train again and again or schedule weekly training batches, which are even more expensive, just to keep the model updated. So again, we built a steady inflow of data so that at any given time, as long as the production lines are running, the model will always be updated with the up-to-date data, and the leaders will have enough data to make the right decisions at hand. So this is an example of one of the conversations we had. I just picked it out randomly. So here a user is saying, I'll be starting a new project with a particular customer for their braking systems. What compliance requirements should I follow? Now this is a very open-ended question. And this is the answer the model produced. So initially it's going over, summarizing over the data, saying, over the past few decades of working with this particular customer's braking systems, we have had a lot of compliance shifts. Specifically, you'll need to meet the ISO requirements for functional safety and performance. But what's even more interesting is that even though with this customer they haven't worked with advanced driver assisting systems, it's recommending to the question that since advanced driver assisting and cruise control systems are becoming so prominent, it's important to focus on the cybersecurity compliance too. And this is a pattern it has learned over the data set, over a large set of documents. But when asked the question, it can extract the exact information, but also look at overall patterns and extrapolate on top of it. So the impact this made was that getting data to take decisions went from taking weeks, containing a huge process from collecting the data to using analysts, to retrieving it to seconds. Okay. I think we are, in conclusion, I think we are at this interesting point in time where currently we are not looking forward in history, or looking forward into the future to see when AI will come or when it will impact our businesses. It has transformed from a question of if it will impact to obviously knowing it's now. And it's a question of when, and it's up to us as enterprise AI leaders to take the strategic lead on. And this is a quote I use often, and I'm very happy that I get to use it here in this particular building. With each new day in Africa, a gazelle wakes up knowing he must outrun the fastest lion or perish. At the same time, a lion stirs and stretches, knowing he must outrun the fastest gazelle or star. It's no different for the human race, whether you consider yourself a gazelle or a lion. You have to run faster than others to survive. So if you are an enterprise who considers yourself a fast gazelle or a carefully pouncing lion, I think it's time to take your run at enterprise AI. And I think we also said that. Thank you, everyone.